to Physical Science class with me, Teacher Mitzi, your Physical Science teacher for this semester. Have your pen, paper, and module ready for today. We will learn about the formation of heavy elements here in our Physical Science class. Are you ready? Let's go! In your previous years, you have learned about the different theories of the origin of the universe that eventually led to the formation of galaxies, solar system, and other heavenly bodies, right? As a review, which of the following is the most accepted theory about the formation of the universe that explain why it continues to expand? A. Big Bang Theory. B. Divine Creation Theory. C. Steady State Theory. Or D. Oscillating Theory. Pause to answer. Are you done? Very good, science-minded learners. It is the Big Bang Theory. Big Bang Theory states that the formation of the universe began through the explosion of a primordial atom which happened 13 billion years ago. It also explains the continuous expansion of the universe. Which of the following is not considered as light elements? A. Helium. B. Hydrogen. C. Lithium. D. Iron. Pause to answer. Are you done? Very good, science-minded learners. The answer is letter D, iron. Right after Big Bang Theory, protons and neutrons combine together to form light elements such as hydrogen, helium, lithium, and beryllium. Which process is responsible for the formation of light elements? A. Big Bang nucleosynthesis. B. Stellar nucleosynthesis. C. Supernova nucleosynthesis. Or D. Terrestrial nucleosynthesis. Pause to answer. Are you done? Very good, science-minded learners. The answer is Big Bang nucleosynthesis. Big Bang nucleosynthesis is the process of producing light elements during Big Bang expansion. I guess you are now ready to learn our lesson for today. But before that, let me first introduce to you to our objectives. Have you ever wondered what stars are made of? What kept them shining so bright? Are there stars that do not spark? Well, this lesson will help you understand some of the important concepts about stars. Are you ready? Now, let's dive into what's new. Okay, science-minded learners, you will going to label the sequence of star life cycle. Use the hints or clues found in your module on page 7. Pause to answer. Very good, science-minded learners. Stellar or star life cycle begins with a giant cloud of gas and dust known as nebula. Then, due to the gravity in the nebula that pull together hydrogen gas until it spins faster and becomes ignited, a protostar was formed. Due to strong gravitational force, the protostar collapses and its temperature increases. When the core temperature reaches about 10 million Kelvin, nuclear fusion occurs. It begins to contract, glow, and become stable. Hydrogen is then converted into helium, and the protostar has become a main sequence star. Let's now go to the average star. The first star to form in this category is the red giant. Pressure in the core decreases. Gravity squeezes the star that hydrogen burning core. The star is unstable to generate heat when it runs out of hydrogen in its core, and it leads to the contraction and expansion. It cools down and glows red. Then helium fused into carbon. When majority of helium in the core has been converted to carbon, fusion decreases. Red giant star becomes exhausted of nuclear fuel and it is depleted. Over time, the outer material is blown off into space, leaving inert carbon. The remnant is called as white dwarf. The next star is what we call the black dwarf, and is said to be the remain of the white dwarf that cooled down and no longer emits light and heat. On the other hand, a more massive main sequence stars evolve. It cools and expands faster than low mass star and will turn into red supergiant star, the largest known star. Carbon fusion still occurs and oxygen is formed. After the super red giant star is the explosion of star or supernova. It releases large amount of energy, and because of that, elements are dispersed into the space. This creates more heavy elements than iron through fusion. This is what we call the supernova nucleosynthesis. Next is the black hole. It is the region in space where gravity is too strong that no matter can escape from it. Lastly, the neutron star that is believed to be formed after supernova explosion. This is also the smallest star. So science-minded learners, here is the sequence of the life cycle of a star. Please pause to check your answer. Were you able to label all the stages of the star? Very good, science-minded learners. Through this life cycle of the star, heavy elements are formed, and this is what we call the stellar nucleosynthesis. To understand further, answer the following questions. Now, let us proceed to the different nuclear fusion reaction that helps to form stars into different stages and creates heavy elements. First reaction is the proton-proton chain reaction. Proton has a charge of very good, positive, and like sign, very good, it repels. So science-minded learners, how does proton-proton chain happen since we all know that proton is a positive charge and like sign repel? Pause to answer. Are you done? Very good, science-minded learners. Proton-proton chain happen due to large kinetic energy of protons that overcome their electrostatic repulsion. Proton-proton chain reaction happens in main sequence star. This is the process by which average star gets their energy and convert hydrogen into helium. It starts with two protons fused together to form deuterium, an isotope of hydrogen. When one proton collides with deuterium, helium-3 is formed. Two helium-3 collided and will form helium-4, and that is the proton-proton chain reaction. However, case is different in massive star. They undergo CNO or carbon, nitrogen, and oxygen cycle to convert hydrogen to helium. You can see in this diagram how carbon-12 is fused with hydrogen and formed nitrogen-13. Since nitrogen-13 is unstable, it undergoes beta decay to form carbon-13. Carbon-13 is a product of beta decay, therefore it is now stable. Carbon-13 captures hydrogen and produces oxygen-15. Oxygen-15 is unstable. Again, unstable elements undergoes beta decay, and oxygen-15 produces nitrogen-15, which is stable. Nitrogen-15 then fuses with hydrogen and gives off helium and ends up with carbon-12. Then the process repeats again. And that's how carbon-nitrogen-oxygen cycle converts hydrogen to helium. Next, nuclear fusion reaction is the tri-alpha process that happens in red giant star. This is how 3 helium-4 are converted into carbon. A star accumulates more mass and continues to grow into red supergiant. Alpha particle fusion happens at its core and creates more heavy elements until iron. This is known as the alpha ladder process. And that's how heavier elements until iron were formed. Now, how do elements heavier than iron are formed? Pause to answer. Are you done? Very good, science-minded learner. As the energy at the core of the star decreases, nuclear fusion cannot produce elements higher than iron. Different pathway is needed for heavier elements to be formed, and that pathway is what we call the neutron capture. Neutron capture is where neutron is added to a seed nucleus. Here is the representation of how neutron is captured and heavier nucleus is formed, where A is the mass number, Z is the atomic number and the number of protons and electrons, X is the seed nucleus, N is the neutron, and Y is the heavier nucleus formed after neutron capture. Here is an example. Iron with a mass number of 56 and atomic number of 26 captures 3 neutrons and formed heavier isotope of iron with a mass number of 59. So how did we get it? First, we must multiply the number of neutron captured with the mass number of neutron, which is 1, and the product will be 3. After that, we will just add the mass number and atomic number of iron and neutron. 56 plus 3 is 59, and 26 plus 0 is 26, and that's how we found the product of neutron capture. Let's try another examples. Are you ready? Let's go! Pause to answer. Are you done? Very good, science-minded learners. Here are the answers. The generated isotope, when unstable, undergoes beta decay, where the nucleus has fewer neutrons and 1 extra proton. Therefore, the atomic number, or Z, increased by 1 and the mass number remains the same. Here is an example. The unstable iron-59 undergoes beta decay to produce cobalt-59. -1 when added to the atomic number of iron will become +1. So 26 plus 1 is 27 and 59 plus 0 is 59. So as you can see, one proton is added and becomes new nuclei, which is cobalt, and the atomic mass remains the same. Let's try another example. Pause to answer. Are you done? Very good, science-minded learners. Here are the answers. Neutron capture has two processes. First is the S process or the slow process, and the second is the R process or the rapid process. S process or slow process happens when beta decay almost always occurs before another neutron can be captured. R process or the rapid process, on the other hand, means that the rate of neutron capture is faster, that unstable nucleus may still be combined with another neutron just before it undergoes beta decay. This is what happens in a supernova, forming heavier elements than iron, and this process is known as the supernova nucleosynthesis. And that is all about how heavy elements were formed. What do you think are the importance of these elements? And how can we use this in our daily lives? Pause to answer. I hope you have learned something. Now, let's move on to our activity. Please get your learner's activity sheet. There, you will see a star with the topic written on its center. Fill out the parts of the star with all the concepts you have learned in our lesson. After answering the activity, let us now move on to our 10-item multiple choice assessment. In your learner's activity sheet, encircle the letters of the correct answer. Thank you, science-minded learners. Until next fun-filled science adventure. Bye!